So this is an example of how to do a chi-squared test for independence on R. So we need to have a situation that we're dealing with, so I'm going to get you some information. This is an example that I'm going to look at that had to do with some archaeologists looking at something that's happening at Burt Mesa Pueblo in Bandelier National Monument. And their question is the raw material used by the prehistoric Indians for stone tool manufacture independent of the archaeological excavation site? So in other words, depending on which site it is, does that say what kind of material they used? So here's a table that gives you that data that talks about the different type of material and the two different sites they're looking at. So we're going to go ahead and look at this process. So the very first thing we have to do is type the data into R. And this is a little different than what you've done in the past. You actually put in the rows. So we're going to do row 1 equals and then type the data in, still combining them, so still need the C. And the first row had 731 as a data point and 584. So we're going to type those two values in. Then row 2 had the values of 102 and 93. Row 3 had the data points of 510 and 525. And row 4 had 85 and 94. I do want to caution you, if you happen to have row totals or column totals, you don't want to include those in this information. This is just the data that was measured. Row totals and column totals are calculated, so we just want the measured data here. Now what I have to do is combine these all into one big data table, so I'm going to call that data.table. And we use a process called rbind. And rbind will bind row 1 with row 2 and so forth. If you have only 2 rows, then you'd only put the 2 rows in. If you have 5 rows, you just keep adding on the different rows until you get them all in there. Put commas in between each one. Hit enter. And the data is there. If you want to, you can look at data.table to see the data. So here you can see you have that data in a table just like you saw in the example. And now we're actually ready to do the chi-squared test. So what you do is, because we're doing a chi-squared, we're going to do in chi-squared. Chi is C-H-I and then squared is S-Q in this case. Dot test, that's the way we do all hypothesis tests, is you do the name of the distribution and then dot test. And then you're going to put in data table, because data.table is where you actually put the data. So data.table is where we put it. You hit enter. Here is your chi-squared value. Your test statistic value is right there. And here is your p-value. So you can now make your determination about whether or not you should fail to reject or reject HO. If you need to look at your expected values, you can also do that. So what you do that in that case, you do chi-squared.test, data.table, and then after the parenthesis type in a $sign and expected. And what that will do, it will display the expected values that were calculated in the chi-squared test. This way you can look at them and make sure that all of them were greater than or equal to 5, and they all are.